Hello everyone, today we are going to continue our conversation about the quadratic equation. However, today we are not going to focus on solving it. Instead, we are going to look at the features of the solution and to see there are some tools to help us. Can we tell how many roots or how many solutions of the equation without solving it? So when you look at the title here, you probably are very confused. What is this? What does that mean? So let's just pause that idea because later, very soon, you are going to know what it is. So before we start, let's just quickly rethink about the graph of quadratic function. So we know a graph of quadratic function look at a parabola. Sometimes it's open up, sometimes it's open down. So what we mentioned before is whenever we are looking for, hey, what is let's see, this ax squared plus bx plus c. This is a function. And what's a solution of this equation? Where do we see from the graph? As we discussed before, it's actually coming from x-intercepts. So it's actually coming from here. And as you can see, this equation, this function graph intersect x-axis with twice. So we are expecting two solutions here. However, we haven't seen this before, but there is a possibility if the graph like this, as you can see, it's only touch the axis once, then how many solutions you are expecting for this equation have then? Then how about, what if this is a situation? You see this doesn't touch x-axis at all. Does that mean this has no solutions at all? So that's something we are going to discuss today. The very first thing, let's revisit the quadratic formula. As we mentioned before, quadratic formula is a universal way to solve for a quadratic equation, because no matter what kind of quadratic equation, we can always figure out a value b and c, and then plug into the equation, we can just find the answer. But today I want you to focus on this part. We are not solving it. Instead, we are going to look at this part. So some students might say, why do I have to pay attention to this part? So the reason is, as you can see, this is if, whatever the b value is, this is just value, this is just value. However, this is under square root. So some features can be changing if this is under square root. Let's see, for example, if I give you square root of 16, you can easily tell me 4, right? If this is just plus minus, like the symbol here, I know there's a 2 value, plus or minus 4. Then what if this is a square root of 0? Then it's only 0. So no matter you give me plus or minus 0, it is still 0. So if this is 0, then this part is basically gone. Then what about this part? If I can have square root negative 4, what does that mean? So some students might say a equals negative 2. This is actually wrong. The reason is negative 2 times negative 2 is actually 4, not negative 4. So that's why for this one is not a real number. The reason is there's no value we can find, but just based on real number system here. You may wonder, can I just see it's not a number? No, because in the future we are going to learn something about this. Anyway, let's go back to this. So it seems that for this case is if b squared minus 4ac, this is whole part under square root, greater than 0, we are expecting 2 value here, then I can say this is a 2 real roots. Again, roots same as solution for this equation. So you may wonder, why do I have add real roots? It's very similar to this one, because in real number system, this is a 2 real roots, or I can even say 2 real different roots. And for this one, if equal to 0, I can only expect, because this part is gone, I can only, so this is going to, 1 real root, or you can say solution. So for this one, as you can see, this one is actually indicate if I give a less than 0, then probably I'm not going to expect anything. It's going to be no real roots. So we are going to leave the conclusion here, and then we're going to look at another functions. Let's visualize the graph of this and to see how they go. Now, this is, if you go to decimals, we know we can just get the graph easily. So I'm going to give you a 3 equation here. As you can see, while I do this, you already start seeing graph. So for this one, as you can see, we have 2 x-intercepts. So does that indicate we actually have 2 solutions? And let's check another one. So later we are going to revisit this one again. See, this is exactly touch once. And this one, it didn't touch anything. So what we are going to do right now is we are going to check what is b squared minus 4ac for each one. So let's say for this one, let's change the color. So b squared minus 4ac. So we know for this b is -6, a is 1, c is 5. So b squared minus 4ac for this case is going to be -6 squared minus 4 times 1 times 5. So it's going to be 36 minus 20 is going to be 16. C is positive, so we indicate 2 roots. Now, let's check this one. So this one, we probably are going to save the time here, so I just write down what's the value here. So it's 4 squared, this is b, minus 4 times 1 times 4, and 16 minus 4 times 1 times 4 is also 16, 0. See? 1 roots. So exactly matching to this equation is 1 root, and this is 2. Lastly, let's see what happened here. B squared is going to be -5 squared minus 4 times a is 1 times 7. -5 times -5, 25, what I'm thinking. Minus 4 times 1, 4 times 7, 28, -3. Less than 0, guess what? No real roots. But some students might wonder, does that mean this is just no real solution? Or just no solution? It actually has solution. But this solution is actually under, what do we call this, like in a bigger number system, which we're going to discuss very soon. Okay, so as you can see, we actually use this idea to verify how many solutions we can expect without solving it. And one thing I just want to remind you is, so this, the whole part here, this is what we do. We only use b squared minus 4ac to determine how many solutions. That's why this part, we are called this discriminant. This is actually back to our title. Discriminant is the whole value of b squared minus 4ac. We can use that to easily tell us how many roots do we have. Okay, so that's a lesson I want to share with you. I want to stop at the graph here, so hopefully that will give you very clear idea what kind of solution we are expecting, even we don't need to solve it. So I hope this video is helpful to help you understand what discriminant is, and use this one to look at by the quadratic function in a very new perspective. Thank you so much for watching this video and study this topic with me. Thank you so much, and take care everyone. See you soon.